Hey guys, it's Miss Chang here. Before I start this video here on this review, I just want to say thank you for those of you who are watching this video because that tells me that you're taking the time out of your long vacation to do some math with me, and I truly appreciate that. Now, as you guys have read, if you've read my email, I have canceled the Chapter 6 Part 2 test because I don't want to burden anyone with the stress of taking a test when we get back, if we get back. But that being said, I don't want to take away any valuable education from you guys if you truly want to practice your math. So here is the Chapter 6 Part 2 review. All right, so we're going to start with question 1 here, and this is all about solving equations. So when you're solving for a variable. In this case, you're solving for x. So this first one here, I noticed that there is a base, and both of the bases are a 2. And we learned that when the bases are the same on both sides, they cancel. And so those 2's goes away, and now the 8x, let me do that with my marker, 8x minus 1, the exponent comes down, and the other exponent, 2x plus 9, comes down. And now I can solve this like a regular algebra problem, where maybe I'll add this one to this side so I can get all the numbers on one side, and maybe I'll subtract this x to the other side so I can get all the x's together. So I'm going to first add over 1. That's a little bit easier. I like to deal with positive numbers more. So that gives me 2x plus 10. I'm going to subtract the 2x from both sides. So this would cancel. This 8x minus 2x gives me 6x equals 10. And now, well, to get rid of this 6, I have to divide by a 6. Now, the 6's cancel for the x, and the x drops down. 10 divided by 6 can be reduced, right? If we think about it, what number divides into 10 and 6? They're both even numbers, so I know 2 divides into 10 5 times, and 2 divides into 6 3 times. So this is really, well, let me grab my pen here, really 5 over 3 as my final answer. Now, this isn't a log problem. Notice this is an exponential problem, so you don't need to check your answer. So remember, we are checking our answer if it's a log problem, like this 4 here. So before we get into that problem, let's do number 2 here. So number 2 is kind of like number 1. The only problem is the bases are not the same right away. So if the bases are not the same right away, you want to try to change the base so that they're the same base. So you want to ask yourself, okay, whether the, let me grab my pen here, whether the 27 and 3 can be both the same base. So I know that generally the bigger number, I can make it look like the smaller number. So generally we want to change the bigger number to look like the smaller number. So 27, I think that 3, if you multiply 3 times 3, you get 9, right? But if you multiply 3 3's together, 3 times 3 is 9, times another 3 is 27, and this works. So that means I can change this 27 into 3 to the 3rd power, because this here is basically like saying 3 to the 3rd power, right? And so if this is 3 to the 3rd power, now I can bring down the other stuff, which is the 3x that was here. So I'm going to put that in parentheses. So this 27 changed into 3 to the 3rd power, and the 3x comes down. And I put that in parentheses because I know I have to multiply whatever new exponents I have. All right, now I'm going to bring down the 4x minus 5. The bases are now the same, so I know that they will cancel. So this will become, you know, that the 3's cancel. Now, when I look at this side here, this is going to be 3 times 3x, which ends up being 9x. And then this side is 4x minus 5, which I'll just bring down. And now I'm just trying to simplify. So maybe I'll bring all the x's to one side by moving the 4 over. So if I subtract 4 to both sides, 5x comes down, negative 5 comes down. I have to divide by 5. And then x equals negative 5 divided by 5 is negative 1. And I guess that's it. You know, x is equal to negative 1 because x is now by itself. All right, number 3 here. It's getting trickier. So now we have a base and another base that's a fraction. So when I'm looking at this, I see that this is a 10 and this is a 100 in the denominator. Now I know 10 can be, if 10 is squared, it gives me 100, right? 10 times 10 gives you 100. But this 100 is in the denominator. Now I'm starting to think, well, if I want something in the denominator, all I have to do is make it a negative exponent. And this will drop that 100 to the denominator. It's a skill that we learned earlier on that might help us out. So what I'm saying here is I can replace this guy here with 10 to the negative 2 power. Because if I do that, this exactly means 1 over 100, okay? And the reason why I want to do that is because I want to have the same base as this side, which is a 10x plus 6. But don't forget the exponent that was there before, and I'm going to put it in parentheses, because remember, if you have this new exponent that you're replacing, that you're using for this base, that this new exponent gets distributed to everything in the old exponent, so it multiplies. All right, so now the bases are the same. I'm going to first actually distribute this in, just so I don't forget. So this becomes 10 negative 6x plus 2 times 7 is 14. 10x plus 6 comes down. Like I said before, the bases are the same, so they cancel. And so I have x plus 6 equals negative 6x plus 14. So I'm going to I like to make my numbers positive, so I'm going to add 6x to both sides so I can have all the x's on one side. So that part cancels. This becomes 7x plus 6 equals 14. I'm going to subtract over 6 to both sides, so that cancels. And this becomes 7x equals 14 minus 6 gives me 8. Okay, I'm starting to run out of room. So what I'm going to do is kind of shrink this just a little bit or move this to the side. So now I have to divide this by 7. So that would cancel if I divide by 7. So x equals 8 over 7. And you can put this in your calculator and just round to, I'm going to probably round to 3 decimal places. But I'm just going to leave the answer like this. I don't like to pull out my calculator if I don't have to. So I'm just going to keep it as a fraction. If you have a fraction, I would just try to reduce it. 8 over 7 doesn't reduce. So that's all I can do. All right, let me refocus this now. So that's the first few problems. Let me get this to focus to 4. There we go. All right, so number 4, this is a log problem. So the first thing I'm going to notice here is like x is inside the log. To get inside the log here, you have to get rid of log 4. Now we learned to get rid of a log, you need a base. So you're going to need a base of 4 to cancel out with this log of 4. So whatever that log's base is, we use the exact same base to cancel it out. But then we have to do a 4 on this side. So that gives me 3x minus 3 finally dropped down from the parentheses. And now I have to figure out what's 4 to the 5th power. So I'm going to grab my calculator. By the way, if you're doing this at home, a lot of the stuff you won't have a graphing calculator, which I can understand is a disadvantage if you don't have one at home. But keep in mind, your computer is really powerful. I bet if you Google a graphing calculator or use Desmos graphing calculator, or just type into the Google search engine, like what's 4 and use the caret button, or the, if you guys remember, it's like this arrow button. If you hit Shift 6 on your keyboard, you'll get it on your computer keyboard. So feel free to use your computer as your calculator. It will work. Play with it. So 4 to the 5th power, or 4 times 5, 4 times itself 5 times, is 124. Okay, and now I have to maybe add over 3, so I want to get the x by itself, so I'm trying to get everything rid of. 3x comes down, and this becomes 1027, not 100. 1027. Now I'm going to divide this by a 3. Now I'm going to do this part in the calculator, just because I don't think this is reducible. So I'm going to try though. So if I divide this in my calculator, oops, oh, I'm going to have to clear that. Let me do that over. 1027 divided by 3. Yeah, this is not reducible. So the number to this is going to be 342.333, a bunch of 3's here. And then that is my final answer. But this is a log problem, so you should check your answer. And it's a very quick check here, because all you have to do is take this number and kind of evaluate. So if I plug in 342.33 into this x, notice this is a very big positive number. If I multiply it by 3, I'm just going to get another bigger positive number. It doesn't matter if I subtract by 3, it's still going to be positive, which is good. Because in a log, you don't want to have zeros and you don't want to have negative numbers. So this will be fine when I plug it in. So I'm going to bubble that in as my answer and put a little check mark. So it kind of reminds me that I've already checked my answer. This will give me a positive number inside the log. So this works. All right. Moving on to the next problem here. So this next problem, I have a 10 as a base and a 6. Now, generally, I would be thinking, oh, well, maybe I can do something like this, right, where I make the bases both the same and then try to cancel. But the problem is that 10 is made up of a base of 10 and 6 don't have much in common, right? Like 6 is comprised of 2's and 3's, but neither of those bases make a 6. And 10s are made up of 5's and 2's, but neither of those, if you wrote it as a base in an exponent form, you could not get a 10. So when you can't figure out what number to make the bases the same, then you start to use logs. So logs help you get rid of a base. So my problem is that x is right here as the exponent. I want to get rid of this base 10. Well, to do that, all I need to do is write a log 10 in front of the 10x. So what I'm doing is I'm literally just putting a log 10 in front of this 10x, and I bring it down. And when I do that, this here goes inside the log in its own parentheses, okay? But I have to do it to the other side too. So I'm going to write a log 10, and then inside of it, I'm going to write the 6. So anything I do to one side, I have to do it on the other side. And so the advantage with this is I don't have to figure out a base that works for both sides. I'm just going to use a log to cancel. So then the log and the 10s cancel, x comes down. And this is log 10, 6. Now I'm going to just use my calculator here to figure this out. You can actually type this into Google as well, or just find a log calculator on Google. So when I type this in, let's see, log base, put a 10, put in a 6, and I get a decimal number, which makes sense because we were having a hard time figuring out what the base could be to make it the same. So this is going to be 0.778 as my exponent that causes this 10 to be a 6. All right. Next one here is number 6. Number 6 is a problem where you have the x right here on the 4. Now, like this one here, I could, one of the things I could do is use a log to cancel out this 4. But before I do that, one thing I recommend doing before you use a log is to always try to get the exponential or the base by itself first. So what I mean is the 7 is not part of the exponential. So I'm going to move that to both sides by adding 7 to both sides. And then this cancels. 4x comes down. 2 plus 7 is a 9. And now when I look at this problem, I'm like, okay, this is a 4 and this is a 9. 4 can never have the same base with a 9. So I'm going to have to use a log again. So I'm going to do a log 4 so I can cancel out with this 4x. And then I will have to use a log 4 on the other side because I chose to use a log 4 on the left side. So I have to choose to use it on the right side as well. So this will all cancel out the log and the 4. X will come down. And then I need to figure out what's log 4, 9. And that I will use my calculator. And so put in a 4, put in a 9, and I get 1.585. And then that there is my final answer. All right, so we've done the first 6 problems. Let's try another 6 of these before we are done with solving. Okay, so now we are on to some more log problems in this section here. So we did a bunch of exponentials. Number 7 here is an interesting log because you have 2 logs on both sides. They also have the same base, and this side doesn't have any logs. So one of the things that I'm going to be, trying to solve is for x. But the problem is that I can't get rid of these logs if there are 2 of them. So what we have to do is try to condense. You might remember me trying to condense using one of the properties. So there's a property saying that if the log is being added, then we use multiplication. So there's like one that says that if the log are being added, then you can condense them using multiplication. So that's what I'm going to be doing here. So because I notice that this is a plus sign, so I'm going to bring these 2 logs together. And also both of the logs are a base of 3, so I can definitely bring them together. So this will be x times x plus 8 on the inside. And this side will still just be a 2. I'll just drop it down. And so because they're multiplying, I have to distribute this x inside. And this becomes log 3 x squared plus 8x. And then this side is a 2. So from there, I need to start thinking, okay, I need to get to x. The problem is that I have this log 3 in the way. So I'm going to have to use a base of 3 to cancel out. So I have to use a base of 3 on the other side as well. So the 3 and the logs will cancel out because that's what bases and logs do. They cancel each other. And so then x squared comes down, 8x comes down, and then this is saying 3 to the second power. So 3 to the second power is like 3 times 3, which is 9. So all I have to do next is, well, I have 2 x's. Well, one of the things I'm going to have to notice is that this is a quadratic. Anytime you have a quadratic, you should be thinking about putting it into standard form. So when you put it in standard form, meaning all the x's and the number is on one side and the other side 0, when you do that, it's easier to factor or use the quadratic formula. So I'm going to have to move over the 9 so that this side can be a 0. And then this side can be x squared plus 8x minus 9. And so I'm going to try to factor because it's a quadratic. And multiples of 9. So I have to think about what number multiplies to give me 9, but adds to give me positive 8. So maybe 9 and 1 might work. Let's see. If I put my x's down, this is a 9, this is a, oops, sorry. I meant to write a 1. I'll make the 9 a positive and the 1 a negative because 9 times negative 1 gives me negative 9, but 9 plus negative 1 gives me a positive 8. And so this works. And now I can set each one equal to 0. So that's why we like to find factors, so we can set them all equal to 0. And then we would just subtract off 9. I know this is looking really squished, and add 1 to both sides. So this first x is going to equal negative 9. Let me write this over here. X is equal to negative 9 for the first one. This one, x will equal 0 plus 1, just a 1. And then that is it. That's all I can do. All right, so this next one here, oh, wait a minute. I totally forgot. Let me backtrack a little bit. Before we call this done here, we always need to check our answers. Almost forgot. So if I plug in negative 9, I already see a problem. If I plug in negative 9, what will happen is that this first one here will be a negative number inside. So will this one. Negative 9 plus 8 is negative 1. So this first answer actually doesn't work. If I plug in a positive 1 into here, this will just be a positive 1. Positive 1 plus 8 is a positive 9. And this works. And so this here is the only valid answer, not the 9 or the negative 9. And that's it. So it's really important to check your answer because one of them might fail. Okay, so now let's get into this problem here. This one, I noticed that the x is already by itself. Well, if x is already by itself, all I have to do is figure out what log base 5 is. And that, I can just use my calculator. So this is really just a calculate problem. So if I, plug this into my calculator, this is log base 5. And then I get, I'll show you what number I get. So x equals 2.3219. So I'm going to round to 3 decimal places, and that's it. So I just plugged this in the calculator. This was a number I got, so x must equal this here. And that's it. By the way, sometimes I'll write the x on the right side. It really doesn't matter as long as you're showing that it equals whatever value. This one here is like the same scenario as part 8. So this one, the x is already by itself. All I have to do is figure out what is log 11.7. And so I'm just going to use my calculator here, go to log base, type in 11 and then a 7, and I get 0.8115. So I'm going to round to 2, and then that's it. All right. And by the way, I didn't check these answers just because I'm not plugging this number in for the log. Notice that I don't have to plug it inside the log, so I don't need to check it. Okay, this next one here, we're back to an exponential. So this exponential has a 4 on this side and a 262. Now, I'm kind of lazy sometimes, and I'm not going to try to attempt in my calculator, can this 262 have the same base as a 4? I could try to do that, and maybe it'll work and maybe it won't. The fastest way to do this problem is just to try to get rid of the 4 right away, because we want to get to x. To do that, we have to get rid of the base 4. To get rid of a base, we use a log. So I'm going to do a log base 4, and then inside of the log, I'm going to put the 4x minus 1. That means I have to do a log 4 on the other side. And so when I use this log, the log and the 4 cancels, dropping down the x minus 1. And actually, how about I go figure out what this number is? So I'm going to do log 4 262 in the calculator. And so I'm pressing that in, putting a 4 262, enter, and I get a decimal number here, 4.017. I'm going to round to 3 decimal places again. And then I need to add 1 to both sides. The 1's cancel, x comes down, x is equal to 5.017 if I add 1 to it. And so then that there is my final answer, because x is now by itself. Oops. Okay, and now for number 11 here, one of the things about like these problems and like problem, I think it was like number 6. So number 6, you might remember me saying like the exponential needs to be by itself. Well, logs work the same way. Logs need to be by itself before you try to get rid of them. So this log here has a base and it has the x minus 7 inside. What's not part of the log is this 2. This 2 is outside the log, so we're going to try to divide it off. Since this 2 is sitting next to the log, it's implying multiplication, so we're going to use division to cancel. And so when I divide that 2 off, I have to divide the 2 to the other side. So this side is now a 4, since 8 divided by 2 is 4. And now I have a log base 3, x minus 7 on this side. Now, the x is inside the log, so to get there, we need to get rid of log 3. To get rid of a log, we use a base. So we're going to use a base of 3 on both sides, so that way we can get rid of the 3 log 3. So that all gets rid of. X minus 7 comes down. Now, 3 to the 4th power, so I'm going to do 3 to the 4th power in my calculator, and I get 81. And now I'm going to add 7 to both sides, and x equals 81 plus 7, which is going to be 88. And looking at this, remember this is a log problem, so if I, pop in or plug in 88 into the log, 88 minus 7 is a positive number. It's 81. So this is safe to plug in since we got a positive number inside the log. So that is my answer, and this is valid. So I'm going to check it off saying that I have checked this answer. I did check this one as well, so I'll check that. This one here, the x is inside the log. So technically there are like parentheses around this x here. Now to get to the x, we have to get rid of the log 81, so we need to bring back a base. So we need a base of 81 to cancel out with this log 81. So we have to use an 81 on the other side. So now I have to think, okay, what is my x? What is 81 to the 1/4 power, right? So I can use my calculator to do this. So 81, use the power button or the caret button and do 1 divided by 4 or 1 over 4. Division is the same as a fraction. And I get 3 as my answer. And so this here is my final result. Okay, so this is the end of part 1 of this review. I'm going to do part 2 in the next one since it will become way too long if I do all of the review in this video. So I'm going to break it down into 2 parts. So please watch the other video if you're curious to see how the other problems are worked out in this review. Bye guys.